Everything we've developed for our cars, the batteries, power electronics, the advanced motors, gearboxes, the software, the AI inference computer, it all actually applies to a humanoid robot.
Tesla redesigned Optimus Gen 3, cutting the number of components by nearly 70% compared to the 600-plus parts in the original Gen 1 prototype. Key sections like the chest, elbows, and knees are now cast as single pieces, or 3D printed, allowing the Giga Press to complete an entire torso module in under 1 minute. So, what exactly in this new design allows Tesla to speed up production so dramatically? How does the new design make Optimus Gen 3 easier to mass produce? Tesla's Optimus Gen 3's design isn't just an incremental upgrade. It signals the birth of a mass production revolution for humanoid robots, a transformation Elon Musk consistently emphasizes as a pivotal turning point for both Tesla and the robotics industry. With plans to produce 10,000 units per month at Giga Texas by late 2025, according to internal Tesla sources and tech media, Optimus has moved beyond a technical demo. It's entering commercial-scale production, much like how the Model 3 helped make electric vehicles mainstream. Musk has stated plainly, mass manufacturing is the real challenge, and if we crack that, the robot revolution begins. Gen 3 was engineered to solve that very challenge. Tesla reduced the mechanical parts count from over 600 components, including screws, micromotors, and joints seen in Gen 1 and Gen 2 prototypes, to under 200 modular or cast pieces, like elbows, knees, and torso, which makes industrial-scale assembly faster and more feasible. As a result, what used to take days of manual work can now be completed in just 2 to 3 hours on automated production lines, with a greater than 98% quality pass rate, according to early 2025 trial runs at Giga Texas. Tesla also applies industrial-grade metal 3D printing for complex components, such as the chest, shoulders, and knees, reducing material waste by about 30% compared to traditional CNC machining, while shortening the turnaround from design to usable parts to just 3 to 5 days. Currently, Giga Texas's 3D printing line delivers roughly 5,000 components per week, supporting its initial 10,000 robot per month goal. Another bold innovation lies in applying Tesla's body-in-white philosophy from the Model Y and Cybertruck, using Giga Press to cast major body structures. Each main torso of Optimus Gen 3 can now be welded, assembled, and painted in under 10 minutes by automated systems, significantly boosting consistency and minimizing human error. Tesla hasn't built a separate robot factory. Instead, Musk is reusing its automotive ecosystem. From welding robots and assembly arms to defect detection cameras and auto-calibration software, saving hundreds of millions in capital investment while speeding up mass deployment. In a company-wide meeting in early 2025, Musk emphasized that Tesla would produce 5,000 robots in 2025 and increase to 50,000 the following year, starting with internal use, then rolling out to customers, with the end goal of creating machines that serve every household. Tesla is betting heavily on its vertical integration advantage, from 4,680 battery cells and power electronics to the shared AI between its cars and robots, as well as its homegrown automation software. Optimus Gen 3 is not just a new robot, it's a symbol of industrial scalability. According to Digital Habitats, if Tesla reaches 1 million units per year, production costs could drop below $20,000 per robot, and possibly as low as $10,000 with continued scaling. This vision drives Tesla's constant refinement of the Gen 3 design, with each engineering tweak aimed at lowering costs, simplifying production, and maximizing replicability. In a Twitter post shared by Musk, he proudly declared that Optimus will be the biggest product in history, and projected 500,000 to 1 million units could be produced by 2027, forming a new labor force far beyond traditional machines. In this landscape, Gen 3 is no longer a lab-bound prototype, but the production-optimized model designed to turn the idea of a large-scale robot factory into reality. If Tesla maintains its current speed and precision, Optimus Gen 3 could become the first humanoid robot ever mass-produced at million-unit scale, a milestone no competitor has reached. And more importantly, it will prove Musk isn't just making bold promises, he's delivering the robot revolution in real time. How is Tesla leveraging existing production lines to build Optimus Gen 3? Tesla didn't build an entirely new factory to produce the Optimus Gen 3. They turned their massive existing car plants into production sites for humanoid robots, leveraging a decades-built ecosystem of automation technologies. This sets Tesla apart from top names in robotics, like Boston Dynamics, where Tesla simply uses automotive production lines, including welding robots, assembly arms, and the Giga Press, to make a humanoid robot, while Boston Dynamics still relies on manual assembly and high production costs. Elon Musk told employees that by 2025, Tesla expects thousands of Optimus units running in Tesla factories by the end of this year and expanding faster than any product in history to millions of units per year. This is more than symbolic rhetoric. It's a technically grounded goal as Tesla continuously adapts its Giga Texas and Fremont plants, fully equipped with automation, welding, painting, and quality inspection systems, to produce robots instead of building a completely new production line. Rather than investing in a separate robot factory, Tesla reprogrammed the software of its existing welding robots to handle Optimus's mechanical components. For example, robots that weld vehicle frames now weld the hip and thigh joints of Optimus. Paint booths apply coatings to robot frames, and surface inspection cameras that screen automobiles now inspect a robot's wrists and knees. Tesla's full self-driving FSD software, which powers image recognition and decision-making in cars, is reused to control Optimus's sensors and cameras, saving the cost of developing entirely new robot software. Meanwhile, Boston Dynamics, known for Spot and Atlas, continues manual assembly with specialized expensive components. While Spot costs around $75,000 per unit, Optimus Gen 3 is targeting just $20,000. Atlas, once a showpiece, still costs hundreds of thousands per unit and hasn't reached commercial mass production. Tesla also uses the Giga Press, an immense press that can cast a vehicle frame every 80 to 90 seconds, to manufacture Optimus components. The torso or back sections of Gen 3 can be cast in one piece, enabling fast welding and assembly. According to internal Tesla test data, each assembly takes less than 10 minutes. Moreover, Tesla reuses more than just hardware. They've also adapted software proven in cars, fully utilizing sensors and FSD chips for robot vision and decision-making. Competitors like Boston Dynamics must develop new software and integrate LiDAR systems and custom AI from scratch, significantly increasing recurring costs. Tesla is even testing production within its factories. In mid-2024, 2 Optimus Gen 2 units were trialed on an assembly line in Fremont, performing simple tasks like component handling. This real-world testing alongside other Tesla robots and human workers demonstrates the feasibility of factory-first deployment. By contrast, Boston Dynamics and startups like Figure still depend on specialized production lines, often dispersed and not scalable. Robot prices between $30,000 to $150,000 remain out of reach for mass markets. Even Figure AI, backed by Amazon and OpenAI, hasn't reduced per-unit costs below $50,000 due to small-scale production setups. In summary, Tesla is executing a full A-to-Z strategy in its existing manufacturing footprint: robots, presses, electronics, AI software, and FSD. This strategy saves hundreds of millions in capex and accelerates mass production far beyond what Boston Dynamics or other startups can attempt. While competitors struggle to reduce each component's cost, Tesla already controls the full suite: equipment, software, technicians in its Giga factories. They didn't start from zero. That's why Musk confidently forecasts thousands of Optimus units working in Tesla factories by year-end, rapidly scaling to hundreds of thousands annually, far surpassing competitors. Tesla isn't merely talking about technology, they are deploying it, proving that their deep integration strategy and economies of scale aren't just bold, but real. And it's this difference that will define the future of global robotics.